Hello students. So in this module we'll be discussing about the first chapter of physics, that is motion. Very important chapter students. Fine. So you have to listen to this module very carefully. Now see students, we should know that what is motion, right? Now if I ask you that what is motion, you may define it like, ma'am, if something is moving, it is said to be motion. Yes, you are also right that if something is moving, it is said to be motion. For example, the rotation of earth, right? The moving of fan, or we can say our body is having blood and blood is continuously moving. So it also shows motion. Now students, motion is basically the phenomena of change of position of an object over a time. For example, this is an object at A position. After some time, at time t, it reaches to B. Fine. So here the object possesses motion. Now students, very important thing in your chapter are the physical quantity. Right? So we should know that what exactly do we mean by the physical quantity. Now, all those quantity which can be measured, they are said to be physical quantity. Right students? Now, what are these quantities? For example, mass. Can we measure mass? Yes, of course. Can we measure time? Yes, we can measure pressure, temperature, weight, work. We can measure all these things. Now, if I'll ask you one question, can we measure light? Can we measure light? No. The answer would be no, because we can only measure the intensity of light and the wavelength of light. Now students, coming on to the next thing, that is again very important. See, basically talking about the physical quantity, we were having two. Fine, we are having two physical quantity. The first one you can see here is the scalar, another one we have is the vector. Now, what do we mean by the scalar quantity? Which can be described by the magnitude, right? Which can be described by the magnitude. Now we should know what is magnitude. It is nothing but the numerical value, right? It is the numerical value, like 5 kg, right? So it is just the numerical value, 6 degrees Celsius, fine? So this is what the numerical value is. It means scalar quantity is the quantity which has only the magnitude. It has nothing to do with the direction, right? For example, if I tell you or if I'll ask you to calculate the length of this pen, how would you calculate it? Simply by measuring it. This doesn't matter to you that if it is positioned like this or if it is placed like this, right? It means that direction is not needed in case of scalar quantity. Only the numerical value is needed, and that is the magnitude. I hope this thing is clear to each one of you. And the scalar quantity are time, speed, mass, temperature, distance, energy. Now coming on to the next quantity, that is the vector quantity. Now students, these are the quantities which can be described by both magnitude as well as direction, which means that both the things are needed. Fine. For example, students, if this is a door, listen to this thing very carefully, and my friend told me that you have to open this door, but he didn't tell that in which direction, either to give it a push or a pull. Fine, but I keep on applying a lot of force, initially 20 Newton, then 50 Newton, but still it didn't open. Why? Because I was giving it a push. Fine, but जो door है वो कैसे open होगा? With a pull, right? It means that to apply this force, the direction is also important. Fine students, I hope this thing is clear to each one of you, and it is a very important concept. Now students, here are these are the vector quantities. For example, we have the acceleration, velocity, force, weight. These are the vector quantities. These vector quantities are basically, they are represented by an arrow sign. Fine. Now students, I hope this thing is clear to each one of you that in vector quantity both the things are required. Now talking about the first physical quantity, that is the distance and displacement. Very, very important concept. See students, if a body starts moving from this point and finally reaches to this point, that is B, right? So here this becomes its distance. This is the total distance traveled by the body, right? It becomes distance. Now talking about its displacement, what will be its displacement, students? The shortest distance, fine, or we can say the shortest separation between initial point, fine, and or we can say the initial and final position. So here displacement is this one is showing the displacement, and the total path traveled is the distance, right? I hope this thing is clear. It's very, very important concept. So displacement is the shortest separation between initial and final position. This one is the shortest, you can see here, and the complete path traveled indicates the distance. Now student, if I ask you one question here, that can displacement be zero? Of course it can. In this case, if a body starts moving from this point, consider this as a point, and come back again to the same point. So here the body doesn't show any displacement. So in this case the displacement is zero because there is no shortest separation between initial and final position, as the initial position is also A and final is also A. So in this case there will be zero displacement. Now students, very, very important, coming on to the difference between distance and displacement. I have made this in tabular form so that you can easily understand it. Now students, what is the SI unit of distance? Meter. Fine. And displacement is also meter. Now what is distance? The total actual path traveled by the body, right? जितना भी एक body total actual path travel करती है उसे हम distance कहते हैं, right students? But talking about displacement, I have already explained you this thing, that the shortest separation between initial and final position is said to be displacement. Listen to this thing very, very carefully. Now talking about the second point of distance, it is written here that it is a scalar quantity. Now we all know that why distance is a scalar quantity, because it has a numerical value. It does not depend upon the direction, right? And it is denoted by D without having an arrow on it. But displacement is a vector quantity, so it is shown by the arrow, and it is denoted by the small s. And displacement is a vector quantity, right students? Why? Because direction is needed here in the displacement, as we have already discussed. I'll make your this point clear in a more better way by this example. So just have a look here students. You can see there are two different cases we are having. This is the first one and this is the second one. Now consider this example first. This is a body, start moving from the point A, reaches to point B, and then took a turn onto right side and finally reaches to point C. Now students, the distance covered by the body from moving from A to B point is 5 kilometers, and from B to C is 2 kilometers, right? So the distance here is 5 plus 2, that is 7 kilometers. But talking about the displacement, that becomes 6 kilometer. Why? Because displacement is the shortest separation between initial and final position. So here this is the initial position and this one is the final position, and this becomes the shortest separation, right? But considering this example students, listen to this very, very carefully. The body starts moving from point A, reaches to point B, then it does not show any turn, right? You can see here it again starts moving in a straight line and reaches to point C, right? Now the distance traveled by this body on moving from A to B is 5 kilometers and B to C is 2 kilometers. Now talking about the distance, we can add the distance, that is 5 plus 2 becomes the 7, talking about displacement, it is also remains same, that is the 7 kilometer. Why? Because as we know, the displacement is the shortest separation between initial and final position. So this one is the initial, this one is the final. So here this becomes 5 plus 2, right? I hope this thing is clear to each one of you. Now students, coming on to the next topic, that is the velocity and speed. Now the SI unit of velocity and speed is meter per second, right? Because the distance is represented by the meter and time is represented by the second. So it is meter per second. Now students, you can see here what is the meaning of velocity. The rate at which an object changes position in a certain direction. It means, listen to this thing very carefully students. Here I am saying in a certain direction. Fine. It means that certain direction is needed for the velocity, which means it is a speed plus direction. Or we can say speed in a particular direction. Right? This is what the important thing is. Now students, talking about speed, it is very simple. You all have read this thing in your class 8th. The rate at which an object covers a certain distance is known as speed. So we can say that the total distance divided by the time. The distance covered by the body divided by time gives you the speed. And talking about velocity is the displacement divided by time is the general formula for the velocity. Remember this thing student, velocity is equals to displacement upon time. As we have already discussed the concept of displacement is a vector quantity and hence velocity also becomes the vector quantity, right? And talking about the speed, you can see here is equals to distance upon time. In our previous topic we have already studied what is distance. Distance is a scalar quantity and hence speed also becomes the scalar quantity. Now students, very important thing. Velocity can be 0, negative or positive, but speed can never be negative or 0. It is always positive. Remember this thing. Now students, talking about velocity, it can decrease with time, right? But talking about speed, it can never decrease with time. So this is the major difference between the velocity and speed. Now students, we have already done the concept of velocity and speed. Now coming to the average speed and average velocity. Now what is the meaning of the term average speed? Look here. The average speed of a body in a certain time interval is the distance covered by the body in that time interval divided by time. So you can see here, this is the general formula for the average speed, right? It is the total distance upon total time. So if a particle covers a distance s in a time t1 to t2, then average speed becomes s. S is the total distance, right? So total distance, in the place of total distance we can write s, fine, because s is the distant. Is it the total distance, right? And talking about the time, we will get the complete time by subtracting the final time with the initial time. So this becomes the total time. This is what all about the average speed. Now students, let us look at some of the example to understand the concept easily. Fine, it is based upon the average speed. In traveling from Pune to Nagpur, Rahul drove his bike for 2 hours at 60 km per hour and 3 hours at 70 km per hour. So how will you find out the average speed now? In this case, we know that average speed is equal to total distance covered by the body upon time taken, right? Now, what is distance? That is equals to speed into time. So in 2 hours, distance covered student, we have to multiply the speed with time, right? So in 2 hours, you can see here the distance covered will be speed into time. So this is the speed, this is the time. 60 multiplied by 2, we will get 120 kilometer. And here you can see 3 hours 70 kilometer per hour. So this is speed and this is time. So 70 into 3. We have 210 kilometer. Now student, we should know that what is the total distance covered. Now how will you find out this total distance covered? By adding this distance with this distance, right? Now this becomes your 120 plus 210 is 330 kilometers. Fine. And talking about the total time, because we need time here, talking about the average speed in our formula, we need time. So how will you find out the time now? By adding both the time. So we have 2 plus 3 is 5, right? So total distance covered is 330 divided by 5, we get 66 kilometer per hour. I hope this thing is clear to each one of you. A very, very simple. Now, moving on to the next thing that we are having here is the average velocity, right? This is the concept of average velocity. Now look here. The average velocity of a body in a certain time interval is displacement of the body in that time interval divided by time. So here you can see it's the general formula for the average velocity. That is the total distance upon total time, right? So if a particle covers a displacement AB in a time t1 to t2, then average velocity becomes AB. We are putting an arrow because it is a vector quantity. And we need total time that we'll be getting by subtracting the final time with the initial one, right? Hey students, now this is the numerical portion based upon the average velocity. They are asking that calculate the average velocity at a particular time interval of a person if he moves 7 meter in 4 seconds and 18 meter in 6 seconds along x-axis, right? So we know the formula for the average velocity, right? What is the formula for the average velocity? Total displacement upon total time taken, right? So how will we be getting the total displacement? By subtracting the final one with the initial one, right? And how will we be getting the total time? By subtracting the final time minus initial, right? So for that we should know the distance traveled by the person, fine? So this is the initial one. And what is that? 7 meter. And what is the final? This is the 7 meter, students, right? And talking about here in second case, we are having the final is 18 meter. Now talking about the initial time that has taken by the body is T1. T1 we are having is 4 seconds, right? And T2 we are having is 6 seconds, right? Now what you need to do is to put all these value in this formula and you will be getting here 18 minus 7 divided up 6 minus 4. So here you will be getting 11 upon 2. Fine. And the final answer we got is 5.5 meter per second. A very simple answer. Now students, let's just move on to another topic, that is acceleration. See, you might have experienced this thing if I ask you, जब आप बाइक पे बैठते हैं तो आप एक्सेलरेट करते हैं, राइट? तो आपको एक्सेलरेशन क्या लगता है? That you correlate high speed or acceleration with high speed, right? But this notion is absolutely wrong, because when velocity changes, only then acceleration exists. Until and unless there will be no change in velocity, then there will be no acceleration, right? Now students, here is the body starts moving from the initial velocity u. U indicates the initial velocity. Initial velocity is represented by the symbol u. And after some time, or we can say at time t, it finally attains this velocity, right? So here acceleration is v minus u upon t, fine? Acceleration is velocity upon time. How will be getting the velocity? By subtracting the final velocity with the initial. So here it's the formula v minus u upon t. Now students, For example, I would like to share an example here. You are having a motorbike and you're moving it with a speed of 80 km per hour, and there is an aeroplane moving with 1000 kilometers per hour. So can you tell me that will there be acceleration in this situation? No, there will be no acceleration. Why? Because there is no change in the velocity, and here the speed remains the constant in both the cases. Now students, talking about another topic that we are having is the types of motion. So basically we are having two types of motion. The first one we have is the uniform motion, and another one we have is the non-uniform motion. Now students, it is defined as the motion of an object in which the object travels in a straight line and its velocity remain constant along that line, as it covers equal distance in equal interval of time. So talking about the uniform motion, here it covers the equal distance in equal interval of time. So you can see here a graph has been made here, students. Along the x-axis we are having the time, right, that is in minutes, and along the y-axis we are having the distance in meter. Now you can see here a body in 1 minute shows the 10 meter distance, and here in 2 minutes 20 meter, then 3 minutes 30 meter, similarly in 6 minutes 60 meters, right? So here you can see the graph is in a straight line, which indicates the uniform motion. Fine. Now just look at the example for the for the uniform motion. If the speed of a car is 10 meter per second, it means that the car covers 10 meter in 1 second. So in 1 second it is covering 10 meter distance, right? So the speed is constant in every second. This is an example of uniform motion, right? Now the second we are having is the movement of blades of a ceiling fan. It is also an example of uniform motion. Now students, a very important note. If a body is involved in rectilinear motion, rectilinear is basically the straight line, and the motion is consistent, then the acceleration of the body must be 0. Acceleration will be 0 in this case. Fine, I have already explained you this thing, students, that if a body is involved in a straight line motion and the motion is consistent here, right? If it is consistent, then the acceleration of the body will be 0, as in that case which I have explained you in the motorbike and aeroplane. Now students, moving on to the non-uniform motion, it is a type of motion that does not cover same distance in equal interval of time. So you can see here with the help of graph, you can see here, look at the graph, students. This is an x-axis, y-axis, distance in meter, and time in minute. Now you can see here a body in 1 minute. Fine, you can see it is not uniform here, right? It is a non-uniform type of motion. As you can see here, the body is not covering the same distance in equal interval of time as that of uniform motion, right? It is a kind of, you can say, the irregular graph, irregular shape you can see. Now if a body involved in rectilinear motion, and if motion is not consistent, remember this thing, in non-uniform motion the motion is not consistent because it does not cover same distance in equal interval of time, then the acceleration of the body must not be 0, right? It must not be 0. Now students, I hope the topic is clear to each one of you. Thank you.